Right, but someone's failing your night, so like.
We're gonna finish going over this test and start on second one. Make sure we have enough time. Wednesday's a little short.
Nerds. So,
But
You read it like every single thing that's like, is this exactly how it's played out? Like your
I love the same one. All these things will be on.
But like, so for the rhyming sums, you have to use like a symbol, or we have to use graph.
No, it's nothing. So, yeah.
So it's the same kind of problem, just like others.
For the most part. Again, I can't say everything's going to be exactly the
I mean, you could.
same. And
But will there be things on the test that are not on the study guides?
I think we say
that's really.
the same concepts.
Yeah, that's.
Yeah.
Do you spare the worksheet we had earlier this unit? You get lost.
I jumped, I probably have to be on.
But.
Time.
Alright, so solving by substitution. So for part A, what are we going to substitute u in for?
X squared.
Square, which means du is 2x. So since we have a 2x dx, we can get rid of those and replace that with du. Get rid of that, replace that with u. So we have the integral of cosine u du. And what is the antiderivative of cosine? Sine u plus c. And then sine is, or u is x squared, so sine of x squared plus c.
Wait, hold on, you got told.
Tell me you didn't already have all these answers?
No.
I don't understand.
Post anything.
The improper integrals on the
work.
no sense. Substitution.
Done.
Oh, yeah. I have all of them done with that one little section.
And then I couldn't get past the substitution.
And you just,
Pretty improper.
yeah, it makes no sense. Even the way it shows on Delta Math, like you plug u into the integral, like the bounds.
Yeah, we do that. We've done that in class. We did that over here.
There's
This question over here. We did that for this question. We plugged in u in for here. Alright,
No, but then it plugs u into like one.
yeah, so when u is equal to x plus 3, so du is equal to dx, okay? But when x equals 1, I mean u is equal to 1 plus 3, so u is equal to 4. So this becomes 4. When x equals negative 2, right here, u is equal to negative 2 plus 3, which is 1. So u.
Wait, so when you do U substitution, you have to.
For definite integrals, it does make it easier if you go ahead and put the bounds through it, so you don't have to substitute back
So to find the bounds, plug both of the bounds into.
through what was substituted for u. Yeah.
Okay.
We did it what else in here? I don't think we did definite integrals anywhere else.
Wait, will you go back up? For number 5. Are we gonna have to know how to go from,
So you will need to know that this right here is delta x, which is b minus a over n.
are we gonna have to know how to go from the integral to the Riemann sum or just?
Vice versa. Wasn't bad. You can look at the notes on that section. It really wasn't too bad. But
Well, I
the things you need to know is that delta x is that, and then f of xi is delta x times I, right? Minus it
Plus it.
plus it.
Well, how do you find A and B when you're going from an integral? It's just.
Well, you need to give you a and b.
Okay.
Yeah, the bounds are your a and b.
And then, so you'll just set that equal to delta x to
Yep,
find.
so you look at that. So once you have delta x, find f of x of I, and then plug that into the function. It's honestly a lot easier to go from the integral to the summation than the summation to the integral. Because at least with the integral, you know what your bounds are. With summation, you have to find the value. Now, the nice thing is they do tell you what A is. If you don't have a value here, then A is 0.
Since the test is 2 parts, is part 1 100 points or 50?
Oh, yeah. Yeah, is it 2 full tests or?
I think it was separate split test.
So 200 points. Yo.
That's crazy.
Alright.
Is integration by parts on the second part,
Yes.
and then,
Yeah, everything that's on this first part will be what's on the first half.
so no, okay.
So integration by parts will be on Thursday.
These are like, I feel like I'm on like side. I'm like,
First truth?
Bro, I spent so much.
yeah,
It's sine and tangent, I think.
I'm watching videos.
So yeah, that's it, sine and
I made a
tangent.
cheat sheet.
So when you do that solving by completing the square stuff,
It's just don't know what we've done. Wait, what I know is.
you'll see on the review. It's also in the notes on the second part. Have I given you guys the second part? Yeah. So again, all you have to worry about tomorrow is what's on this.
That's not perfect. I don't know what it is.
I just, there's so much.
Okay. So any questions on part A? What am I substituting in for part B? 5t cubed, which means du is 15t squared, dx, which we have, or dt. So that gets replaced with u, this gets replaced with u, so we have the integral of e to the u du, which is like e to the u plus c, which gives me e to the 5t cubed plus c.
Okay, now I have an issue.
I also have a question, like, on some of the delta map, like, when we go from the integral, like, why is it sometimes there's plus c and sometimes it's not? When do you know?
If you don't have bounds, you have to have a plus c.
Why are you,
Oh, okay.
why are you plugging in, the,
Because you're doing integral u at that point. So you need to find u, to find du, make sure you replace this with du, because we need to do the integration according to u.
so, wait, what is the purpose of finding the?
It basically allows us to do that inverse chain. Or inverse, inverse chain in this case.
But do you even need it?
Well, it gets rid of the chain that because when you do the derivative, you did the derivative of this right here. What's the derivative of e5t cubed? Well, that would be dt. That would be e5t cubed times 15t squared. The du gets rid of that 15t squared, gets rid of that chain for us. It undoes the chain. Yeah.
So you don't have to show it, just that you found it.
You don't have to show anything, just that you know that du is now. The trouble comes when we don't have exactly what du equals to. We have to get what we have and then kind of work a little.
Is that what's happening?
Yes, that's what we want to see. Any questions on B? So C, u is equal to 1 plus 5x squared. Okay. So du would be 10x dx. Now, do I have a 10x? Yes. No. So what I'm going to do, I have an x dx. How do I get rid of the 10? 1/10. So we are going to have integral of 1/10 times 1 over u du. Now, because I have that 1/10, and that's a coefficient, I can move that outside. 1/10 integral of 1 over u. All right, what gives us 1 over u?
Natural
So, natural log, so 1/10 natural log of u plus c. Oh, yeah, actually, with that,
Yeah.
yes.
How did you like u is equal to 1 plus 5x squared, not like 5x squared?
If you're gonna replace something, might replace the whole economy.
Oh, so you can like choose.
You could, I mean, if you just replace it with that, it's going, you get the same answer. It just be a little somewhat more complicated, not really much in this case, because the antiderivative of 1 over u, is you still get the 1/10. Okay, you just have 1 plus u, and the antiderivative of that would be still natural log of 1 plus u. Okay, and then what do? You plug 5x squared back over u, you get the same answer. So yeah, you get the same answer. Might as well just go ahead and cross that.
1 times natural log is 1 plus 5 x squared natural log.
Don't we need to do a 1 plus 5x squared? Yep. Let's see.
But would we be wrong for that?
I will like, I, yeah, why don't we need it?
Because that's a square.
Yeah, it's a square, so no matter what, you're gonna get positive.
The only time you can get the number.
You could, that's what they just said, you could leave it there, and I'd be okay with it, I'd be fine with it. Just make sure you understand if you see it on like an AP multiple choice, that's when you see a multiple choice question, that's why there's no abstract value.
But if x is an imaginary number.
Yeah, but we don't deal with complex numbers. That's a whole other topic. You can go up and go take abstract number analysis.
But there was a model, right?
Yeah, it was a fun class too. You basically take complex numbers from algebra through geometry, trig, and calculus, and just everything's complex numbers. Yes, it was. So, alright. So what would you want to substitute u in for number, or letter D here? Sine x plus 1. That means du would be dx, which I have, cosine x dx. So I get the integral of u to the 1/2, which is easier than just square root u. Du, which gives me, if we take, and for this, don't forget, we add 1 and then divide by the results. So we're gonna get 2/3 u to the 3/2 plus c. And since u is sine x plus 1, we get 2/3 sine x plus 6.
Wait, why'd you add +1 to the?
Because it's in the.
That's the integral.
That's you knew.
Would you be fine if you have kept it like that?
Yeah.
It's not complicated that.
Okay.
I mean, if you do more, I'll understand, but don't. Yeah, don't. Yeah, don't. You don't have time for that. Mr. Willett, he'll be here tomorrow. I mean, I have put, if you have a, you have an IEP that gives you some time, you give you some time, but other than that, you'll be done by the end of class.
How long is the test? Is it doable in now?
I mean, yes.
Like, is it longer than a regular test?
No. That's why I split into 2 tests.
It's a normal.
So there's no bonus on these tests just because I don't want you guys focusing on that instead of actually completing the
Oh,
test.
so you're just gonna give us all the points of it? Please. Please.
What?
Why don't we turn in our study guides for 2 extra points?
Why'd you divide it by 3 over 2?
Please.
Because when doing the inverse power rule, it's like if you do derivatives, what we do is we multiply by the exponent and subtract 1 from the exponent. The opposite process of that is to add the exponent and divide by the result.
Yeah, just figure out.
It's just we're not having a good.
So here again, you don't have to use the 4. You can leave the 4 there. You can say u is equal to x squared, it'd be fine, but might as well just say u is equal to x squared plus 4, which means du is equal to 2x dx. Now, since we don't have a 2, but yeah, 2, so we're gonna have 1/2 the integral of u to the 1/2 u
Okay, I know the bad ones, so.
Wait, so you're dividing by two because you don't have a two?
Yeah. You want to get CX. I don't have a 2 though, so
Oh, okay, I see.
so I can replace XDX with 1/2 new.
1/3 new to 3/2 plus.
Okay. Third u to the 3/2 plus c, and since u is x squared plus 4, make sure you plug that back in, don't forget c.
So we will lose points if we leave it as you.
Yeah.
Okay. Look at that. I just want to see it. I found it.
So that's what's in your test. So let me look at your test. Here I know. Can answer any questions you have specifically about the test.
You invite what,
Two.
like, grand function derivatives, like we should, that's like, other than sine and cosine, like, can.
Sine, cosine, tangent. I mean, really, I'm not going to focus a lot on the trig stuff because that's not the question on these. It's can you do the specific type of integration?
So just sine, cosine, and tangent.
Yeah, that'd be really it. And not even tangent, to be honest. What? Okay. All right. So it's- all right. So again, it's not going to be in that specific order. That the first thing you do is Riemann sums. Okay. But it will be the question for Riemann sums will pretty much be this, just different numbers. Okay. This question will be a little different. It'll be multiple choice. Okay. Honestly, I find it to be a little bit easier. You'll actually have 2 multiple choice questions about this. Okay, one very easy. I would say very easy. Another one a little more thought. Okay. But if you could do any of these, you should be fine. You can do any of these on your own, should be no issue. Okay.
Yes. Is it?
I mean, yeah, possibly, yeah. So if you can do F without any issue, you should be fine. Yeah. So here.
Property. He is a property. Yeah.
This question, that's honestly very close to what's actually on the test. Okay, this question is very close to very close to the type of question you're going to see in the test. Yeah, so if you can do 3, just make sure if it says leave your answer in terms of pi, you leave your answer in terms of pi. Okay, so yeah, it's pretty much the same kind of question, just different numbers. Okay. You will be asked to write a definite integral based on a graph. Definite integral is an integral that has bounds. And they give you the equation. Yes, it's a simple equation. It's a very easy question. It's worth just a few points because that's how easy it is. Okay. But it's the only question that's not on the review. And you just need to identify the bounds from the graph.
Because I just want to be able to write it down so I can.
I mean, I could try to find one from the notes.
Yeah, I was gonna say there's one on.
Yeah. Question 6, again, very close to the question on your test.
Is there 9 questions on both?
No.
9 questions?
No.
Or more or less?
More on the first one, about 9 on the second one, I think. I think there's 11 on the first and 9 on the second. All right.
Is there multiple choice questions on the your response?
It's a bit of both. There's a bit of both on both.
They're not all multiple choice.
Let's see. there'll be a question like this one. The difference here is you don't have the function, you have the graph.
You don't need the function, it's crap.
Yeah. So you will be able to solve geometrically, which means you do need to have how to find area of triangles and rectangles and circles. Okay.
Well,
No, I give you the graph. You have to find area of a circle. No, I will not give you the area of a circle. No, you have to know that. You do need to know the difference between total and net.
Always when you put
It's absolute value.
Total is absolute value. Net is if it's below the x-axis, it's negative.
Wait. Not just like if you do the line you're saying.
No, it's not. It's not that hard either. There are a lot of triangles and stuff like that. I told you have to know rectangles, triangles, and circles. So yes, you could do trapezoid if you want, but you can also split a trapezoid into rectangles and triangles. If you're not, yes, you can. I assume you can. All right, you will have questions like these, just not as many. I think I only have 2 questions like these. Okay. Be able to answer anything from A to H. Okay.
Will there be a value to ones?
You mean E? Using E? Let's see here. Yes. Kind of like how you had for number 9B. Oh no, I was wrong. There's 13 questions on this test. With severals A through B. It's only 4 pages, though. Yeah, the rest of it is really simple. Like in the entirety of page 1, page 2, and page 3. Honestly, the only trouble I see anyone having will probably be on the very last page. Wait a second. No, it's only 12 questions. I think I looked at the wrong test. Because I took one of the, remember, I took one of the questions, like I told you, talked about average value of an integral. I put that in the second test. It was still on there, so I must not have saved it. Well, it's the very last question on the next review. And it's also very simple. But yeah, honestly, this test is very, very, very easy. It's very easy. The only issue that people tend to have is on these questions. Okay, for some reason. These should be honestly very simple. Okay. You just replace your variable with you replace t with x. Okay. And if your x is in your lower bound, you make it negative. Okay, make the function negative. If your x is a function like you have with g and f, g, and h, or e through h, you have to do the chain. Basically, do the derivative of the bound.
So when we find the
Wait,
So again, like for e here, we replace r with x, so 1 plus x. Well, replace this x to the 6th times 2x times the derivative of the bound. That's it. F of x.
we have to find it of the resulting.
No, they're saying that they want you to take the derivative of this integral. And what do derivatives and integrals do? They cancel out. The difference here is you have x in your bounds. So what you're doing is you're taking, in this case, capital F of 1, okay, minus capital F of x, okay, and you're doing the derivative of this, d dx. So that would just give you, this would go away, because derivative constant is 0, minus tangent x, because capital F of, well, the derivative of the integral would just give you the original function, wouldn't it? So yeah, that's it for letter C.
H.
Sure. Didn't we already do H?
Yeah, but it,
Okay. So again, you could do this a couple ways. You can do this a couple ways. If you want to go ahead and just make it negative and flip it, 1 minus 4u squared, negative 1, cosine t. When we take the derivative of this, and that would actually be u because u is in my bounds. Okay, when we take the derivative of this, what does the derivative integral going to do? They're going to cancel out. No, these are not improper. So the derivative and the integral will cancel out, which will leave you with cosine of my bound. Now, in fact, negative cosine of my bound, 1 minus 4u squared, times the derivative of that bound. And what's the derivative of 1 minus 4u squared? Negative 8u. Negative times negative is positive. 8u cosine of 1 minus 4u squared. If you have trouble with that, okay, you could just
So
do the derivative.
as a rule, basically, plug it into the integral by parts, and if it's just like a number, like a -1, you just don't even think about it.
yeah,
Yeah, because the derivative of a constant, because if you plug in -1 through the integral, it becomes a constant, right? Yeah, and what's the derivative of constant? 0. So again, this is the like, if you're just going to take it at face value, this is the way to do it. What you're really doing is you're doing negative f of 1 minus 4u squared minus f of negative 1. Okay, and you're taking the derivative of this. Okay, this is what you're doing. The integration would look like this. Okay, capital F of one function, the upper bound, minus capital F of the lower bound. Okay, which is the antiderivative. All right, this right here is a constant. So we take the derivative of a constant, it just becomes 0. All right. Now, what is the derivative of a function of f of x? The derivative of this right here would be f of 1 minus 4u, lowercase f now, 1 minus 4u squared, right? Squared. All right. Times the derivative of what's inside, because you still have to do the chain rule here. What's the derivative inside? A negative 8u. That's where we get this right here. So f of this is cosine of 1 minus 4u squared. So again, that's what we are doing when we take the derivative of the integral. They cancel each other out. You just have to put the bounds through it, okay, and do the derivative of the bound. So you can make it as simple as complex as you want. Okay, the simple way to do it is replace this with my bound. All right, replace it with your bound, and then multiply it by the derivative of the bound. Again, let me just get rid of all that because it's just a mess. So again, replace this. Now, since it's in the denominator, it's going to be negative cosine of 1 minus 4u squared, and then multiply it by the derivative of the bound. I mean, that's as easy as it gets. Okay, replace t, my variable, with my bound, and then multiply it by the derivative. Why don't I worry about that with like letter C? Why didn't I worry about it with letter C? What's the derivative of x? It's 1. Derivative of x is 1, so we don't have to worry about the derivative of the bound because it's just 1. But when my bound is another function, you do have to worry about it because it's not just 1 anymore. Again, it is really not all that complex. Okay. Now, integration by parts, yeah, that's complex. I will agree with you. It's a challenge. Okay. Improper integration can be a challenge, but it's really not that bad. All right. Any other questions about what's on the first test? So it is 12 questions on the first test. Okay. So 12 questions on the first test. Easy tests.
Yeah. Two. One. One. Not eight. Eight.
Over.
All right, and it is 10 questions on the second test. So 12 on one and 10 on the other. So it's off by one on each. So
Can you go back to F on the front page on number two? The work is not working.
which one?
F on the number two.
Part.
How is the answer set?
Oh. We did this. It's the same question as A. Once we get it down to this, it's the same as A. Doesn't matter what your variable is.
Did you only know that because you had already done the problem?
What?
Or was there like a way?
I mean, it's use the same process as A if you want. So. No, you do exactly the same. It's just since we already did it, we just wrote 7 because we already had it done. And somebody said, what, G on this one?
Yeah, why is it negative 1 over x squared? Or this times below over x squared.
All right. So this gives you the natural log of 1 over x, right? Times the derivative of 1 over x. What's the derivative of 1 over x? Negative 1 over x squared, right? Again, though, it should be what? I'm missing something here. Times the value of 1 over x.
Can we just post, I mean, like, obviously work during most we can, but can you just post the instruments on the second one?
Second one, what?
The test review, or if we don't finish it?
Oh, we're not finishing.
What happened to today?
No, we're not finishing today. We still have Wednesday.
Oh, we're doing this Wednesday?
And today.
Yeah.
Today and Wednesday. Any other questions on the first test? Again, it will look very similar to what's actually on your review. You will, I mean, a lot of the same kinds of questions. For the derivatives of trig functions, you do need to know the derivative of sine, cosine, and tangent.
You just said no derivative. That's like the 1 over x. No, yeah. Oh, that one? That's like.
No, inverse. I'm talking about sine, cosine, tangent.
Oh. I don't know if I.
Why did this thing?
There's a lot. Not like
That's one.
this is ours. It is a Barbie dream house because we couldn't find a real gingerbread house. It's our name. No, it was bad. It's on a rooster.
So, no other questions on that? We're going to move on.
This is me fine. I'm fighting. I was jumping like with a piece. I remember, so it was fine.
So,
Integration of others. I didn't know that.
So happy. They are super and not see everywhere. Out
So which best represents the following definite integral? Yeah, I might as well get started on this today, so make sure we finish and answer any questions you guys have on Wednesday. So this one was a little fun to make up. Okay. Now, again, the question on the test will not look exactly like this. Okay. But it will have the same concept.
Utilize the formula.
Yeah. So what is, since this is integration by parts, what's the formula? So integral of uv prime dx is equal to what? Uv minus integral of u prime v dx. Maybe. Yep.
Yeah, I'll listen to.
Oh,
Right. So it's new number two. So now in this case, u is f of x, right? V prime is g prime of x dx, which means v is g of x, and u prime is f prime of x dx. I'll calculate that a little. Let me try writing that without it being so close. So u prime is f prime of x dx. There we go. So now, since we don't actually have values or anything here, since we have bounds in this case, okay, what do I have to do with the f of x and the g of x when I plug this in? So f of x and g of x that go here, so it's f of x, g of x. Because I have bounds, I have to do what? Yeah, put the bounds in. I have to do f, if I had f of b, g of b, minus f of a, g of a, then I wouldn't need those bounds. Okay, but since I don't have that as an option, I need those bounds. So that automatically means a, b, and c, and even e doesn't work. Answer D.
I think what's the correct email?
Yeah.
You find the difference between F and G view, like
You plug the bounds in like you would normal integration. So f of b, g of b minus f of a, g of a.
Explain how this is gonna be different on the test.
You'll have values. Yeah, you have numbers. You'll have a chart with numbers. So for f, g, f prime, g prime.
And is it gonna give you like A and B?
You'll have the actual values for the bounds.
Wait, so
And it'll also even tell you, I think it also even tells you what this is equal to. So you don't have to find that. You just need to know this. This is kind of the important part here.
that you just have to think about.
Yeah. So you need to know how to do that. And then since they're going to give you like f of 1 and g of 1 and f of 2 and g of 2, you're going to want to plug those in and actually solve, find an actual value. Okay. And I think the question gives you this value. So say this is equal to 2. Okay. So minus 2 whenever you're done. So yeah, that's the difference. It'll be in the question on the test. Here, I just wanted to make sure you know how to get to this point. Right. Not bad. Integrate. Do not use your calculator. Exact answers only.
into the.
So this is that. Not U substitution. Integration by parts. All right. But in this case, since let's see, might be able to. Well, in this case, all right, we are doing that. What U is what, and V prime is something dx. Question is, do we want to? You can choose which one. You can actually choose which function you want to be U and which function you want to be V prime. Okay. Now, the question is, which one's easier to find the antiderivative for? X squared. So you want this to be x squared. That means V would be what? Yeah, the derivative of this. No, the antiderivative of this. So that would be what? 3. That would be 1/3, right? 1/3 x to the third. And we have that this is natural log of x, which means u prime is 1 over x dx. So putting everything together, we have u v minus the integral. Now the uv, what? 1e. We still have to do that.
One x for V prime.
It's not just my equal sign kind of integrated to my fraction. All right. From 1 to e of, was it u prime? 1 over x times v. X cubed. Sorry, I'm jumping steps. Let's not do that. U prime v dx. So let's plug my u, my v, my u prime, my v in. So u is natural log of x times v, which is 1/3 x squared, x cubed, from 1 to e, minus the integral from 1 to e of 1 over x times 1/3 x cubed dx. Any questions on how we made it here? Again, looking at my two functions, since I can't do integration by substitution because that would not get rid of the ln of x, and I can't do ln of x because that wouldn't get rid of x squared. It's just, if you try to do substitution, it will not work. Okay, and no matter what you substitute for, it will not work. So in those cases, you do integration by parts. And though this is why you can choose which one is it easier to find the antiderivative for. Okay. So for example, if I had something like x squared e to the x, honestly, e to the x is easiest to find the antiderivative for. Okay. So u would be x squared in that case. Now in those cases, since my e to the x would never go away, you'd probably want to do that Tableau method, if you remember. Don't worry, we'll do one. All right. So, since we chose u to be natural log of x, because it's a whole lot easier to do the antiderivative for x squared, u prime is 1 over x, derivative ln of x dx, and the antiderivative of x squared is 1/3 x cubed. So since I know my setup is uv from the bounds of 1 to e minus the integral from 1 to e of u prime v, I plug everything I know in. Now, we start with e, natural log of e times 1/3 e to the third minus natural log of 1 times 1/3, 1 to the third power. Now, natural log of 1 is what? 0. So we end up with 1 times 1/3. So I end up with 1/3 e cubed here. Minus. Now, we can make this a bit easier. What happens to the 1 over x and x cubed? Squared. And what's the antiderivative for x squared? 1/3 x cubed. Now, we already have a 1/3, so 1/3 times 1/3 is 1/9 x cubed from the bounds of 1 to e.
Why did you what? No.
Why did I what? What number specifically?
Yeah.
How did you? I was following along and that.
You guys are very specific in your questions. You know, and really easy to point out where the issue is.
I don't know, you guys are connected, so I understand.
I would say it's like,
So yes, the 1 over x and the x cubed canceled out to x squared.
Just 9 points.
To get the antiderivative of x cubed is 1/3 x cubed.
How do you know?
X-
You know what's plugged in.
Plug in for x, bounds.
I did the opposite.
If you substitute E and you substitute
Trying one, what's the, I want to bet.
You didn't substitute in for e.
but you went,
I know B equal.
Oh yeah, because my bounds here are 1 and e. So you got to put them through the bounds through. So you do the ln of e times 1/3 e cubed, ln of e 1/3 e cubed, minus ln of 1. ln of 1 is 0. Times 1/3 to the 1 power, which is just 1/3. Now 0 times 1/3 is just 0.
I was thinking,
oh, okay.
I was thinking,
So that just went away. So we just bring this whole thing down. This is 1. So we just end up with 1/3 e cubed. For that part anyway. Now, just again just a second. That's why I want to spend some time with on this as well. Any questions about the second half? The integral from 1 to e of 1 over x times 1/3 x cubed dx. Any questions on that? What happens to the 1 over x and the x cubed? What happens to 1 over x and the x cubed? They reduce to x squared. But what's the antiderivative of x squared? 1/3 x cubed. We already did it, so it makes it pretty easy. 1/3 x cubed. But we already have a 1/3. So 1/3 times 1/3 is 1/9.
how do you know when to do this, when to do U substitution?
No.
When you can't do u substitution, you do this.
Why couldn't you do U substitution?
What would you substitute u in for?
I love X.
What's the derivative of ln of x? Do you have 1 over x? No, you have x squared. How would you get rid of x squared with 1 over x? You wouldn't. That's why. You can't. Yeah. Yeah, you can't do that.
Yeah.
Yeah.
Well, as long as they're not both on something, that's fine.
That's the thing, yeah. You would end up with x cubed times u, but you have two different variables you're trying to do the integration of now, and you can't do that. So yeah, you cannot do u substitution in this case. There's no way to substitute u in that would get rid of both x squared and L of x. So since you have two separate functions here, it's honestly when you have what's considered to be the product rule in here. Okay? And our product rule cannot be removed by that u substitution. So yeah. And you have to be somewhat careful because we also did integration by parts with just the ln of x. Because what's the antiderivative for ln of x? There isn't one. Yeah, there isn't one. So we had to do integration by parts, and we just made v equal to 1 in that case. Just to finish this though, 1/9 e to the 3rd minus 1/9. This becomes 1/3 e cubed minus 1/9 e cubed plus 1/9.
You said you had a spare.
What?
You said a spare worksheet, like the one.
Oh yeah, let me print it out. Oh.
Well, if you can just.
You can, I mean, you can, there's no point. If you want to waste your time, go right